Okay, so
One, one,
that is
one quick
started.
thing. Um, as far as our rocket goes, we do have our major components for the subsections, but some people, we're on break right now at RPI. Some people did take subsections home and kind of the rocket. We have the rocket and all the components. It's a little bit dissected right now.
Okay. Um,
Just
what
letting you know.
what subsections were taken home?
So we have our av bay is kind of we have our sled and everything, but part of it was taken home, so the sled isn't fully complete. I could show you if I could go grab it. And then our payload is the members of Will. Will's on call. He it's a little bit in pieces right now because we're kind of optimizing it, but we have all the components, like all the everything fit together in the rocket for the most part.
Okay. As far as the payload goes, my main concern is stability and shifting of the payload, assuming if it's not deployed. I'm still concerned about shifting, even if it is deployed or not. So, if you can kind of show me on the payload how it's being stored within the rocket and how whether or not it'll flop around and all that sort of stuff, then that's fine. So, um, if we want to start with the rocket, we can do that, and we can go from there.
Yeah.
So it's your choice.
Okay, so we have a short slideshow, quick, that does kind of give an overview of the whole project,
Okay,
and
perfect.
then I guess I can give some time if Constant there and Luke are sitting together there, they can go and get the rocket. Um,
Yeah, we have it set up.
you have it set up? Okay, all right. So I guess um, I can
Okay,
start that. Let me share my screen.
all right.
Should we go bring it in here?
Okay, are you guys able to see this?
Yes.
Yep.
All right, all good.
All good.
Okay, so this is the intro to the safety review for Team 74. Um, okay, or yeah, and then as far as just a general system architecture goes for this, uh, the airframe has the fins are custom machined and it's attached to a filament wound fiberglass composite body tube and nose cone. Both of those are COTS components with the SRAD fin design. The propulsion for this is a approximately 16,000 newton second N class motor with 2,900 newtons of average thrust. This is APCP base. This is the SRAD motor. The flight systems are entirely COTS, and we did this to ensure nominal recovery, as that is what we have experience with. And the payload for this, which we'll go into more detail later, is student developed muon detector intended to develop these particles as a function of detect these particles as a function of altitude. And Kate, if you want to talk about just this simulation.
Glad to see you using Raz Arrow.
Yeah, we've been doing a lot of RAS Arrow simulations, and in order to kind of get these results, what we've been doing is we put in our total rocket length, center of pressure, center of gravity, as you can see, and dry weight and the rough paint, assuming fully turbulent flow. And ultimately, we got that our expected apogee is 33,490 feet, which is slightly above the goal of um, the 30,000 feet for the 30,000 SRAD competition. And uh, this will this is kind of exactly where we want to be, because due to like wind speeds or unexpected weather conditions, it's always anticipated that your altitude will usually go a little bit lower than the simulation. This is kind of exactly where we wanted to be in terms of our RAS air results. Max velocity is Mach 1.8, and our thrust to weight ratio is 15.7 to 1.
Okay.
Constant and Luke, are you guys still on the are you guys still getting the rocket? You guys there? Okay, if you guys want
I
to talk
just set it
about
up. So our propulsion system, as Rowan said earlier, we're using a 98 millimeter APCP bait screen or APCP chemical composition for our propellant, and then our grain geometry is actually 5 base grains with a 1.25-inch core, and then one 6-fin finical grain, which is 12 inches long. So it's twice the size of each base grain, and our total propellant length is 42 inches. The way we test our propulsion system is through static fires, as you can see a picture on the left of the static fires. That was the first one we did. So far, we've done another one. And then using the data collected from the 2 static fires we've done, we created a thrust curve, which is the picture on the right-hand side. As you can see, it's kind of like a neutral regressive thrust curve, um, which the results overall, the designation was an N2900. The peak thrust was 4,950 newtons. The total impulse was 15,920 newton seconds, and the burn time was 5.5 seconds with specific impulse of 219 seconds.
Okay. Let me stop you there. How does that result compare to your simulation? To would you use open rockets or open motor or burn sim to simulate the motor?
We actually use both simulations, and I mean it's pretty close to the actual simulation. I don't have the file on me at the moment. It's close, but it's just a little bit different with the Finicil. How the reality of Finicils versus the simulation. Both are regressive curves overall. Um, this one, the erosive peak is a little bit higher at first than anticipated, and the
yeah.
burn time is about the same.
Okay. What about your pressures?
So our pressure ranges, the chemical composition we chose is less aggressive, so we already don't have. We're not close to overpressurizing the motor, and that was kind of the goal with everything. And our pressures, I don't know off the top of my head, but
I,
it's pretty close.
I can
Const-
Okay.
if Constant wants to pull up those exact numbers, I can elaborate a little bit more on the motor simulations. So compared to our first sims prior to the first static fire, we actually overperformed slightly by, I want to say, maybe like 5 seconds of specific impulse. Um, and our pressures, compared to our original sims, did run slightly higher in ballpark about 50 psi, but that's still well within the safety threshold of the cases and hardware.
Okay. When you said 60, 60. Well, okay. What were when you monitored the pressure in psi? What was the pressures that you saw on your static test?
Constant, are you pulling those up right now, or should I?
you should right now. It's on my computer, Constance, right now. So
Okay.
he's working on it right now, but it's
Okay.
going to take us.
Okay, while
I
he's working on
He
that,
has it right here.
Oh, he has
Yes.
it. Okay.
while he's working on that, can we also have you pressure tested the case?
Are you
So
saying like hydrostatic testing or?
Hydrostatic, yes, I'm sorry, hydrostatic pressure test on the case?
we we have not done that. This is a COTS hardware. This is binder design, Fisher research.
Okay, okay, that's fine.
So that wasn't of grave
Yeah.
concern to us.
That was kind of the benefit of choosing that in our decision matrix was we have something that's been tested and you know tried multiple times, so we don't have to pressure test or hydrostatic test the case.
That's fine, guys. My team uses those same cases, so we're good there. But I have to ask the question. When you're in an SRAD, one of the criteria is pressure test, unless it's a commercial case. So we consider Fisher to be a commercial case. So you're good there. but I still want to know the pressures.
Yeah.
All
All right.
yeah. So I have this peak pressure for this the second static fire over the summer, or just last April. We had a peak pressure of 875 psi.
Okay. That was your max?
Yeah, max pressure.
Okay. How'd that compare to your Sims?
That overperformed the simulation, I believe,
Okay.
by I'd say
That's
100 psi.
that's been my that's been my
Yeah.
observation with the stuff with the propellants that we're running, and we're also running a Finicell, a little completely different configuration, but nevertheless Finicells. And I've noticed that at least I think open motor is the pressure is under what we're seeing. So what we are seeing is what we saw. So in a somewhat like configuration. So okay, I like.
Nice.
Okay.
Good. Good that we're
So
keeping everything consistent there.
well, I just said to you,
Revalidating.
SRAD, you know, when we enter SRAD, we need to ask, I need to ask a lot of questions about it. So, um, you're good. Let's move on.
Okay, sounds good.
Very good.
So to talk a little bit about our flight systems, so this is the picture of our avionics sled. The avionics here being used are the RRC3 Sport for the main altimeter, the 2 Plus for the backup altimeter, two pull pin switches, and a featherweight GPS tracker. These are all altimeters and GPSs that we've used before and have experience with and success in using, and we're confident in continue using that. For the recovery, it's a 24-inch stroke parachute, a 96-inch main parachute, and tubular Kevlar recovery harnesses. These give us the descent rate under drogue. I'll get into that when we look over the technical report briefly. But I believe that was 170 feet per second at max, which I know when you're higher up in the atmosphere, it can go pretty quick. But when you actually deploy the main parachute, it's slowed down to a much more calm, like 120 feet per second. And the main parachute, the 96-inch Rocket Man parachute, that should give us a landing velocity of about 17 feet per second, which we're confident in our rocket's ability to survive that landing.
Okay. Can you show me the batteries?
So the batteries are 9 volt, pretty standard. I know Constant and Luke, if you want to physically see them, they're in the lab and they could find them. But
No, I don't need to see the physical batteries. How are they mounted on that sled?
so I get you can kind of see on by the GPS tracker. Do you recognize the featherweight there?
Yeah.
So right above that, there is this essentially 3D printed holder for the battery, and there is a cover to that, and that is mounted over top, and there's a screw that threads into that and
I
holds it in
think
place.
so. The way we hold the battery, sorry, bro. This is for the featherweight, actually, right here. But
Okay.
our our electronics lead isn't here today, so we all have a good understanding of the project, but there's some like little things that. But the way the batteries are stored are on the back.
Okay. So they're basically stored within some sort of a case or something, then, right? And that
Yeah. So the
case has a lid on it, and you screw the lid down.
Yep. Exactly.
Okay. All right.
That's right off. See.
Perfect. Okay. Um, that picture didn't show. Can we go back one more second? That picture doesn't show anything coming off for the E matches or anything.
Yes,
Um, will you be able to show me that?
so those are just fairly standard, just like I believe 22 gauge wiring. We I guess Constant and Luke in the lab right now can have a better understanding
Okay.
of
Okay.
that.
Yeah. Well, okay. Let me give you just a heads up while we're right here. Um, you can expect your wiring to be checked out extensively in New Mexico at the initial review. Okay, so make
Yeah.
sure everything's tidied down and nothing's dangling, tangling, or whatever. So, okay,
Okay, sounds good. Noted. Thank you.
you, you'd be
This is kind
surprised.
of
Yeah, you'd be surprised how many of those things I can pull and they'll disconnect. So,
so we
go
use
ahead.
sorry.
Go. Okay.
We use Wago connectors for the E match to the payload, and then these really secure. Like I could yank them as hard as I possibly can, and it
I,
stays in
I,
the Wago connectors.
I've heard those words before.
Okay,
Yeah,
it,
yeah.
it's
I mean, just be. All I'm trying to tell you is just be aware that when you arrive in New Mexico and on Monday and you go up to have your rocket examined one more time, that those checking the rocket are going to start pulling on wires. And our experience over the years is a lot of the wires come loose. Okay, so I'm just saying, be aware and make sure that things are tidy and solid. That's all.
I understand.
You know the Waymo connectors. I was at another contest a couple weeks ago, and they were used. They seem to be solid, um, but you may run into some people who haven't even seen those yet. So on that end of it, but they're fine. I don't have a problem. I personally don't have a problem with them. Okay.
Sounds good.
Okay. Next.
So, just a brief concept of operations as far as the rundown of what happens once we get to New Mexico
Mm-hmm.
and onto the launch site. So, it starts with pre-flight preparations as far as like assembling the motor, packing, parachutes, uh, going powering on electronics, making sure everything's okay, to then moving to pre-flight assembly where that is actually preparing the rocket for flight, like loading black powder charges, inserting the motor, making double checking hardware connections and links, moving on to pad integration out on the pad where uh, we have a checklist that we go through, which I know we have to on the technical report, um, where I'm sure you'll see that later, but that details like because we use our own launch tower, so we have to slide the rocket onto the launch tower. Well, before that is completely set up, as that's 10 feet vertical, strapped down, with ratchet straps and stakes. So no putting a rocket on before that. Then double checking continuity once igniters are installed, and before all that, of course, there's altimeters need to be powered on. Then once everybody is back to a safe distance, the motor is ignited and kind of goes through flight. It's pretty self-explanatory. And then we go and recover the rocket, hopefully intact, and get scored.
Okay.
All right, now Will, if you want to talk a little bit about the payload.
Yeah, so I could basically so I could sorry about that. Yeah, I could start talking about what we have prepared for it, and I also have part of the physical assembly here. It's not a totally complete assembly because other members of the payload team have some components, but I can talk in general about how this is basically a plan to measure atmospheric muons as sort of a function of altitude, and write all that information onto a micro SD card to be retrieved after payload retrieval, and then analyzed to see the different concentrations of muons from our detectors at different altitudes. And so you can see right here, this is a CAD diagram right here of sort of the internal structure of it with our aluminum bulk plates and our steel thread rods going through. We have bismuth shields to protect the scintillators inside. So those light blue elements are all bismuth, and inside of them are plastic scintillator assemblies, and I can actually show you that right now. This is a cast. Sorry if you can't see this, but This here is basically, yep, the cast bismuth elements, and then the plastic uh, scintillator on the inside. And so these will connect to what's called a silicon photomultiplier, which measures sort of the light that these muons create within the scintillator. And then it uses a custom PCB from this SIPM. And actually, I have the PCB, at least what we plan to use for the PCB. The rest of the electronics are with another member of Payload, but this is our PCB right here. So it has an ESP32 mounted here. This is the SIPM assembly, and then we also have a micro SD card and a barometric pressure system to measure. And it's all soldered with solder paste, and then it is connected to a nickel metal hydride battery on a plastic sled, which is going to basically be in the lower portion of what you can see on this CAD diagram right here. And then the entire payload will be basically bolted into the rocket body using similar bolts to what we have right. If you can go on my camera. Yeah. So it would be bolted in.
Okay.
Those are, yeah, the same bolts that we will use to bolt it in. And ultimately, the total assembly is going to be weighed out at 10 pounds.
Okay. All right. We'll get into
So
it. We'll
if you have
get
any
into, yeah.
questions about that, that's sort of what we have for payload.
Okay. We'll get into the mounting and stuff when we look at the rocket. So okay. Perfect.
I think you.
So far.
Oh, sorry. Hold on. Let me just mute.
Okay.
So as far as this next section goes, so this is essentially what we had for this slideshow. So now we can either go and show you kind of the construction of the rocket, or we can start going through the technical report if you have any questions on that.
Yeah, I'm not evaluating the technical report, so I don't have any questions on that.
Okay.
Okay. So let's go to the rocket and show me, and let's start at the aft end and work our way forward.
Okay. I'm just gonna, let me interrupt and try to get a better recording real quick. 1 sec.
Yeah, if you can close your screen out, close the slides out,
Yeah.
so we can get a full look at the rocket.
Okay, so here is what we have of the rocket. Out for you. What's not? Oh, sorry.
Yeah.
My camera's off. Hold on. There we go. Can you see it?
Yep.
Okay, so this is what we have of the rocket. At the school with us, because again, people are on summer break and optimizing pieces before we fully put it together.
Okay.
Where would you like to start?
So start down at the bottom, at the aft end where the fins are.
Yep. So here are our fins.
Okay. Right.
They've been machined. We have screws that, when they go in, they're perfectly smooth here to prevent, aerodynamic drag and to secure the fins properly.
Okay. Have you run fin sim on that?
Yes. Right now, so I used the FinSim Lite version because I didn't have access to the full version. But preliminary flutter simulations show Mach 4.4. The fin will flutter at Mach 4.4 at 5,000 feet, which is our maximum velocity, at the altitude which our max velocity occurs. So we have a very high factor of safety.
Good. Rotate around so I can see the motor retention.
So this is the liner. This isn't our motor retainer. So if you go up the rocket from here, our motor retainer is screwed into our rocket, where it's right here. There's a threaded rod that's connected to the top of our
You can pull it out.
motor. We can pull it out if you'd like.
Yeah, I hate to do it to you, but yep,
All right. Okay. It'll be just 1 second.
that's fine.
I just have to help with that.
So you have some sort of a threaded rod that taps directly into the forward closure on the motor.
Yeah, it mimics the AeroPack minimum diameter retainer style, except it's a custom built. It's made out of a fiberglass coupler and a bulk plate rather than the aluminum that AeroPack uses.
Oh, okay.
Yeah, one of the advantages that we saw to this design is the fields around us are limited to an 18,000 foot waiver,
Mm-hmm.
and so we need to be able to modify this and modify the length or the size of the motor that can fly in our launch vehicle to a 2 grain 98 compared to this is essentially a 7 grain 98 millimeter motor. So being able to just drill a new set of holes and shift that retainer down is necessary for our design.
Ah, good. Sounds good.
We're still working on this. There'll be 1 second. We had the screws in, so we threaded
That's
some
okay.
things. So
That's all right. We have time. I hope.
Yeah.
My next one is 2 hours away, so hopefully we won't be too long.
Yeah. Yeah, if it takes 2 hours, we've got something wrong with our design, I guess.
Yeah, I would hope we're not going to take 2 hours. Mine average about an hour to an hour and 15 minutes. Um, some people talked about, doing 2 hours. Um, that's to me a little bit on the excessive side, but whatever. I mean, I just want to make sure that I see a rocket and it looks like it's flyable. So come on and let's try it. I don't want. What we're trying to prevent, and you're probably going to shake your head and say, "My God," but we've actually had teams building rockets in hotel rooms.
Hmm.
And you can't build this class of a rocket in a hotel room and arrive at the field and expect to fly it, as
Yeah.
you well know. It takes more than a couple hours to build this thing. So that's one of the reasons for this video, and that's one of the reasons about you have to show me the rocket, okay? So we know that you're basically well on your way to attending. So anyway. And then we'll start worrying about the safety part of the rocket. So, okay. Oh, cool. I like that.
that's our motor retaining method. Obviously we're going to clean it up a little bit, but that interface to the rocket, that's where you saw it screwed in. It's kind of like the AeroPack.
Okay, so if it's a Fisher case, flip it. Can you down at the aft end where the nozzle is? He's got his normal thrust ring down there.
Yeah. Right now we just have a liner in it, but
That's okay.
yeah. Yes.
Okay, so okay, so when that motor kicks in, where is the force? How is the force distributed through the airframe, or how is the force distributed through the rocket?
So the thrust ring will seat flush against this edge, so it'll transfer all the load along the outer wall here.
Okay.
None of it is being held by this retainer.
Okay. That's okay. Okay. That's what I wanted to know. All right.
Yep.
Okay. And while you're there, rail buttons.
It's we're doing a tower launch,
Oh, you're gonna do your own tower launch? Okay.
Yeah.
Therefore, no rail buttons. Okay. All right. Let's move up to. I don't have anything else on that end. Let's move up to the separation point for the drogue and the main, or however you're an electronics bay, however that's all gonna be occurring.
Yeah, so this, just quickly, this is where the payload bay will be. It'll be bolted onto these two sections will be bolted together. So,
Okay.
so for the drogue will separate here. There'll be four 256 shear pins. Um, we're actually going to do that this afternoon. And
Okay.
then holding the nose cone on will be four 440 shear pins.
Okay. So you're
It's
gonna
a
do.
it's a head end deployment style.
That's exactly what I was gonna ask.
Yeah.
Okay. Okay. Now, oh, I need to, if possible, I need to see the hard points for the drogue and the mains. Where are you going to hook everything up to?
Yeah. So for the right now for the main, there is an eye bolt screwed into the. This is a Wildman
Mm-hmm.
nose cone. So there is an eye bolt threaded into here that the payload, or sorry, the main harness. Can you pull that out?
Yeah.
The main harness is hooked up to. So it's a little hard to see in there, but that's where it's bolted onto
Okay.
or
And
secured.
what kind of eye bolt is that?
This is a one bad hawk harness. It's a 7/16 inch Kevlar.
Okay. Any
So-
burn marks on it?
No, it just looks like general use from. I believe this was one of our members' Kevlar harnesses that they used for L3. So it just has black powder residue on it.
Okay. Big. That's one of the other things they'll be checking in New Mexico is the quality and what shape your harnesses and everything are in. Okay, so if you want to look at it, make sure there's no tears or anything like that in it. You really didn't answer my question on the eye bolt. Is it a closed eye bolt, an
Oh.
open eye bolt?
Oh, sorry. Yeah, it's a closed eye bolt, forged eye bolt. Yeah,
Oh, okay. All right.
it's a little hard to see, but
Do you have your phone? I'll
Yeah,
just
yeah,
put a flashlight in
No, I'll take your word for it.
Okay.
Believe me, I'll take your word for it. And you said that shock line for the main is about 30 feet.
35 feet, I believe. Yeah.
35 feet. Okay, that should be fine. And the main was going to be how big?
90.
Oops.
Oh, cut out.
Yeah,
Um,
almost back.
Oh, I think we lost the connection.
you're good now.
Okay, yeah, it's a 96-inch main.
Can you show me the main?
Yes, I'll.
It'll take 1
Yeah.
second.
Yeah, I'll have to.
That's fine. No hurry.
So
Okay, I just want to let you know.
one thing that I do want to say, actually, so what he's going to grab is not the. It's very similar, but it's not the exact main that we're going to be using. We have a 96-inch Rocketman parachute that is not the high performance model, but because of we're in the process of acquiring the high performance model, just because we need that extra the higher coefficient of drag to provide the safe
When? Go ahead.
just to provide the safe descent rate.
Okay. When do you expect delivery of that?
So it's been ordered. We just need to go in. I would say he's usually pretty quick, maybe like a week.
Okay. When did you order it?
Yesterday.
So we had some debates about what we're doing, and we decided to stay on the safer end of things and get the high performance one. So what you're going to see is our worst case scenario, and as Rowan said, almost definitely we'll have the high performance one in time. So that's why it was ordered later. Was just we kind of had a discussion about it.
Okay. Are you ordering the parachute from Wildman or from Rocketman?
Rocketman.
I would I would monitor that order very closely.
Okay.
There are people who are not getting orders.
Okay.
Don't make an assumption you're going to get it in a week. Um, there's been I'm not sure I know what's going on with Rocket Man, but um, I have a guy here who ordered a shoot 3 weeks ago. He still doesn't have it.
Okay, I guess we
So,
will consider other vendors then.
That's a
so
that's a possibility too. You could look at 3D shoots. Um, I'm just as a heads up, there's quite a bit of chatter about Rocket Man not necessarily delivering timely. So
Okay.
okay,
okay. So
okay,
this is the parachute right here, the non-high performance one we have.
right. Okay, well, it's going to be brand new. Well, what I generally do in this case is I'm checking for holes, tape, patched up parachutes, all that kind of good stuff. So if you're going to be getting a brand new one, it's not going to be a problem. If this one's the one you're going to use in reserve, as long as it doesn't have any holes or patches, well, it can have holes, it can have patched holes as long as it's done correctly and that sort of stuff. So, okay.
Okay, this is the one we have. It doesn't have any holes or anything, but we are going to do a test flight. So let's say, what do you guys view as the correct patches for holes? Like, what is your personal criteria for
Well,
this?
I wouldn't say it's necessarily my point. There is when you're patching up parachutes, there is something called parachute tape that I use. I would give the I won't say give Wildman a call, but I wouldn't say Wildman. Give Pretty Shoots a call. Ask them what the proper way to patch it is.
Okay, thank you.
Okay, I don't. In other words, I don't want to see masking tape for a patch, if you know what I
You
mean.
you definitely won't. I promise you that. I can
Okay.
promise.
All right. Okay. Okay. All right. Um. Okay. All right. Let's move on to the drogue.
We're grabbing that.
Yeah. Okay. I assume that's gonna be wrapped in some sort of Kevlar or something to protect it from the ejection charges and all that sort of stuff.
Yep, we have Nomex.
Okay. Can you show it to me?
Yep, it's it's tough when there's only a couple people in the lab. Hopefully they didn't drop connection again.
Hmm. I hadn't thought about that one. Maybe he did. Can you call him or ping him some way?
Yeah, I can try. There.
We returned.
Yeah.
So here's our main Nomex. Here's our drogue Nomex, and then here's our drone parachute.
Okay. All righty. Let's go back to where the electronics bay would be. Or what I'd like to see is the payload mounting. Um, I know you said there was a coupler and it was basically held in place. Is it possible? Okay.
It's this coupler right here. Again, one of our members of payload has it dissected right
understand.
now because he's optimizing something that
Right.
we didn't really like on it. Here's Will. You can.
Hi. So yeah, this is payload right here. We actually have two of our bulkhead plates, which will goes up right here, and we also have some threaded rods. We have 6 threaded rods that will go in here. Those are standard Quickmaster steel threaded rods to go through each end right here. And then we have also with us, this is the bismuth shielding. So basically, this will secure in right here through sort of thread rod holes right here. And then we have a laser cut aluminum plate that will go over here, and that will secure this floating plastic element right here. And then we will have aluminum spacers to go through the threaded rods up above right here, and eventually our electronic sled with our that's 3D printed with our different electronics and batteries and such, and that will all connect through here. And then I don't have on me right now the ways we are securing the threaded rods, but they're similar to what basically.
They're similar to the basic Master car.
Yeah. Okay. What size are they?
Oh. So we have 2 types. Get exactly off the top of my head. But you can see them right here. So these are our thicker ones, and I believe these are the same as, or at least they're similar in diameter to what's on the bay right here. And these are slightly smaller. I'm sorry, I don't have off the top of my head the specific type. I can get that to you though.
The larger ones are quarter 20.
And the smaller ones?
I would assume something in the ballpark of 832.
I think that's correct. Yes.
Okay. The A32s are for the payload.
Correct.
Yeah, well, these are all for the payload.
Well, they're all for the payload. Okay.
Yes.
All right. Yeah. What's the diameter of the rocket? Is it 4-inch?
Yes.
4-inch minimum diameter. Correct.
Okay. Okay. So that gives you a little bit of space problem. Okay. All right. And how will those threaded rods be secured? What kind of nuts?
Here, I can get them to you. Just what nuts. Oh, yeah. I mean, yeah, just nuts. So.
Okay. All right.
Just nuts.
Okay.
And Loctite.
Yep. Some Loctite, some lock nuts. We'll get it done.
Okay.
Like I said, I have them in the other room, but I can get them.
That's
to you.
okay. That's all right. That's all right. Okay. Let's move on to the electronics.
So you saw the sled from before.
Right.
Rowan talked about it a little bit.
Mm-hmm. Show me your coupler and all that sort of stuff.
This is the coupler. We have a camera mount built into our coupler.
Okay. What's the length between? What's the length of the green area you've got between the green area and the white that you just had your thumb on? What's the length of that extends into the body tube?
Yeah. So that didn't sound good. Sorry, you dropped it.
Slightly less than 1 caliber.
Again, our electronics lead is not with us, but
So
Yes.
I guess one thing I want to mention, so I know the general rule of thumb for that is one caliber, but with the COTS nose cones, that is actually as far of a length that you can slide into the nose cone shoulder, like the shoulder built in inside of the nose cone. So
Mm-hmm.
that's the limit on as far as that goes.
Right.
Um,
And the nose cone is not limited to a one caliber. It's limited to the minimum is is a half a caliber.
mhm.
The one caliber rule applies to anything that separates.
Okay, well the nose cone does separate.
Yeah, right. But the other
Yeah.
end of it, okay, what about the other end? Is that a full caliper?
Yes.
At
Oh yeah.
least, yeah.
It's a little bit more than a cow.
Yeah, it is. It's good. It's a little more than a caliper. Okay.
Yes.
Yeah.
All right.
See?
Okay. Let's look at the bulk plates on both of those ends.
Oh,
Yep, I have one
These are
right
charge
here.
valves and all that sort of stuff.
So here's one bulk plate.
Charge cannons.
Yeah.
Yep.
This is for the drogue side.
yeah. It follows the Jim Jarvis method for high altitude deployment.
Okay, yeah, so you're not going to obviously use CO2. You're going to go ahead and
Yeah,
okay.
we're using black powder. Yeah.
Okay. Can you describe how you're going to build the black powder? No, I don't know. How you're going to load those guns you've got there?
Yeah. So, so the first order, so in order, the E-match will be placed in here. Then the measured out black powder, I believe it's 4 grams or 3 grams, will be placed in, will be poured in, and then the rest of the volume will be packed with cellulose insulation or dog barf, and then it'll be capped off with a little rubber plug.
Okay. All right, that should work just fine. I see your connectors. All your holes will be plugged up and sealed so that nothing
Yep.
can leak. Okay. All right.
Yeah. And the
Yeah.
yeah, and the main side follows the more traditional, smaller charge wells. I believe these are 3 gram charge wells.
Wow.
So,
What's your backup size?
uh, the backup I believe is 2.5 grams, and
Yes.
the main side or the main primary charge is 2 grams
Okay.
for the nose cone. This will be for the nose cone section.
Yeah, they're smaller
There you
because less
Yeah.
area in this concrete.
Right, right. Okay. All right. That looks pretty good to me. I see some washers. That's even better. Okay. All right. Okay. I'm good. You look like you're well on your way. I understand about a payload and somebody in a somebody at home tinkering with the software or whatever they're doing. So that's again that's no problem. My concern is stability and shifting and that sort of stuff. So um, again, a word of caution on Rocket Man and ordering of your shooting stuff. That to me that seems to be somewhat of a critical on your critical line right now. Like I say, you could also go to a different vendor and get the same equivalent if you so desire. And I have heard no other problems from any other vendor other than out of stock or maybe that kind of stuff. Then those kind of problems. Um, I don't. I like what I saw. I think you did a very professional job. Um, I'm going to reverse the table, and I'm going to let you ask me any questions you want. Um, how many? Let me ask one more quick question. How many team members are going to be going back? I have experience with Spaceport.
So this is actually our first year ever competing in Spaceport America Cup. That's why we might not have been the most prepared for this video call. Um, but yeah, this is our first year. We kind of see ourselves as an underdog, and we're doing everything we can. We have mentors that have gone there. We've talked to people who've gone there, and we're trying to set ourselves up for success.
Okay. Okay. All right. So, Bryce or anybody want to ask me any questions? And then I've got about a 2 minute speech. that I'll give you guys some heads up on what's coming down with Spaceport. So, any questions? It's your first time. You must have some questions. It's hot.
Yeah.
Snakes are out
Uh,
there.
I guess I have. Oh, yeah, I guess I have one question about the podium presentations.
Uh huh.
Oh,
I, again, I don't review those.
okay.
I only do safety reviews. From what I understand, you should know within the next couple of weeks, maybe a little bit shorter than that, whether you've been selected or not.
Okay, thank you.
Okay, and, yeah. Same with final report too. I don't even look at them. They've got a bunch of other engineers running around looking at those. So, any questions? Yeah,
Yeah,
go
I
ahead.
have a question. So, sh- sure, your motor. You said you kind of have similar motor that you fired before. With the Finisil and everything like that.
Uh huh.
Um, when you did the static fires, did you do them in a really hot climate, also, or did you do them?
No, no, they were
So,
done. They were done in the fall. In
okay,
fact,
so
we just completed one. We just completed one of our static fires yesterday, and the temperature outside was 70 degrees. I'm just outside the Washington D.C. area, so temperature yesterday was low 70s. There's no way I can simulate 110-degree temperatures.
yeah.
But
So, did you
yeah,
notice a huge performance difference, or like what kind of margin did you notice of difference?
uh, we noticed between what we flew and what we about a 5%. But we weren't going to 30K either, and 30K is a little different. We were only going to 10K, and we were going with a two-stager. So things are, we got big boosters and small sustainers, and
I understand. Thank you.
things are a little different. But yeah, there's no way I can simulate the temperature difference. And burn sim or open rockets don't really handle that real well. So
Yeah, I know you saw the picture we had in that slideshow in the snow. I think that was maybe 20 degrees that day. So
yeah,
between that and the most recent static fire we did in April on approximately like a 70-degree day, so about 50 degrees of difference, we observed, I think it was about 150 Newton average thrust change. So it went from like 2750 to 2900. So it was
mm,
actually fairly significant.
yeah, yeah. Especially when you're trying to take an altitude and you're depending on the altitude based on the weight of the rocket and the thrust of the motor.
Yeah.
And even the commercially available motors have a plus or minus 10%. So you know, but you're right. Most people don't realize that there is a temperature difference and how it will affect a given motor. So very good. I like ambitious project for the first time. 30. Usually, most of the teams come in at 10K first to get a feel for what's going on, and then bump to 30. But
Yeah.
Thank you. We've been developing our experimental program for about a year and a half, 2 years now, and there's kind of with this like milestone in mind. So we didn't want to go for 10K. We wanted to go right for the 30K because we've already been developing this milestone on our checklist. So
Yeah.
okay, I think it got a reasonable good shot at you. It looks like you got a nice rocket built up. You've got really good fins. You've done your homework. So I think that's pretty good. Okay, a couple of things. If you've been monitoring Hero X, I'm going to repeat some information, um, and maybe give you some little extra information. So the first 2 days of the conference are going to be at what we call the convention center. Okay, and there will be the activities of the podiums. There will be an area where you'll have your rocket up and you'll have your display and all that sort of stuff. It's also where the essentially the final safety check will be done. Okay. Um, one of the things we're doing this year that we haven't done in the past is when the team registers, the team leader will be given a pager, and the pager is very similar to what you would get in a restaurant, so that you'll be paged to go to a specific area. Like, for instance, you won't have to stand in the hallway waiting to go in for safety review. You'll get a page, you'll bring your rocket into safety review, and so on and so forth. That pager will follow you out to the field, out to the launch area, and same thing will occur there. They'll page you when like for instance, to come up for the very final safety review, which, and all that really is make sure you got your pins in, your bolts are in place, your fins are solid, that kind of stuff. They don't take the rocket apart or anything like that. They will take the rocket apart in New Mexico, in Las Cruces, at the convention center. So be prepared for that end of it. Um, the It looks like that we could be opening for launching as early as 7 o'clock in the morning. The whole launch cadence and scenarios can be controlled by the wind. And since this is your first time there, the winds by midday are usually in the 10 plus mile range and can easily exceed 20 without even a heartbeat. So if they do exceed 20 ground level winds, the range will be shut down. We can't fly. So when you do your SIMs, do multiple wind conditions, 5, 10, 15, 20 type of thing. Um, and so you can account for that. Um, so, so the pagers will follow you. You don't have to bring tents with you this year, and you don't have to bring tables. We will supply those. The whole area that's going to be the rocket prep area will basically be covered in very large commercial tents. One of the problems we've had in the past is student tents become flying objects, and we got to prevent that from happening. Plus, we want to keep you under the shade as much as possible. Okay. When you're packing up and getting ready to bring things, bring plenty of water, drinks. There will be food trucks out there. I can't guarantee the quality of the food, but there'll be food trucks out there for whatever you need. The launch site itself is a little over an hour from the hotel, so you'll need to, account for that. You'll have to have some sort of a vehicle to get back and forth on that. It is a desert, and it has sagebrush. It has 6-inch thorns that go through the bottom of your shoes. So don't wear sandals, that kind of stuff. Dress for very dry climate, but very high temperature. Okay, 90 plus degree temperatures on that end of it. So I think on HeroX there's some pretty good preparation information about what you need to bring and all that sort of stuff. Um, Other than that, that's about the end of my speech. Again, I'll ask if anybody's got any questions based on what I just talked about. And again, I thought the group, for the first time through, you've done a really good job. It's obvious that you've got some experience on your belt, and it shows. So I congratulate you on that. Well done, well done. Just watch out for that parachute.
Will do. Thank you so much.
Oh, you're welcome. Okay. Anything else?
Uh,
Yeah, I just have one last quick question.
Sure.
Would we be allowed our own communication system, like walkie-talkies?
Yes.
Communicate. Okay.
Yeah. You can. There is. I would think during the first couple of days, when you're registering stuff, let people know that. And I don't know how they're managing frequencies. If you're using FRS, you've got 16 frequencies or whatever it is that you can scroll through to figure out what you're going to put the team on and stuff. When you go out to recover, You'll designate certain people for recovery, and those people will go through, or those teammates will go through a training session Monday or Tuesday at the convention center. We'll give you a backpack, and that backpack has GPS and a radio and stuff like that in it, so we'll actually know where you're at out in the field. So, um, and we'll know when you come back and all that sort of stuff. So don't forget about it is a contest. There are points that are awarded, so play the game.
Will do.
Some points aren't worth struggling for, and some points are really worth struggling for. So just be aware. Okay.
Thank you so much for everything. We appreciate
Oh,
it.
you're welcome. You have my email. I'm not bashful, as you see. If you got any questions, ping me. Not a problem. And we will definitely see you in Las Cruces.
We'll do. We
Thank you
look
so
forward to
much.
seeing you. We'll reach out if we have
I'll be there.
anything.
Everybody have a good afternoon
You too.
and I guess a good weekend coming up. I hope, right? Finals are over with.
Oh yeah.
Good.
Only
Graduation's
up
over with.
here.
Great. All right. Everybody have a good one, and we'll see you in a few weeks. And again,
Thank you.
any questions, ping me.
We'll do.
Okay.
Yeah, have a good one.
Have a good. You too. Bye bye. Oh, you can
Bye.
turn the recording off, and be sure and send the recording off to the email address that I put in my first email.